Hi everyone and welcome to a new video. This video, the title says, what is the fastest way to become a software developer or like a coder? So in this video, what I wanted to do was like I have a list of things that my team has sent to me, which are the fastest way to become a coder apparently. But I feel there is just one. So in this video, we'll be doing two things. The first thing we'll be doing is I will be sharing some tips telling you what's the fastest way to become a coder. But the second thing, more important thing we'll be doing here is I will be going through the AWS dashboard of an existing client of mine. I'll be showing you what their current bill is and how we can optimize this, and we will optimize this and save them a few lakh rupees a month. I think we can do this. And the reason I want to do this in this video is that there's just one real way to become a software developer faster, or like a better coder faster. And that is being extremely curious about this field and doing things by getting out of your comfort zone. That's it really. I have these list of 5 things, and there are a lot of videos on the internet around what's the fastest way to become a developer, but I feel there's just one, and the one thing is being very curious about technology. I'll elaborate a little bit more on this. So yeah, with that, let's get right into the video. So this whole concept of computer science or coding, the first initial motivation of anyone trying to get into this field is money. But I think that should change very quickly. If you keep that as your motivation, very early you'll lose motivation. And even if you don't, you will learn how to do something specific. For example, you learn how to create a website in PHP or a backend in PHP, and then you'll keep doing that for the rest of your career. This happens because you know how to build that thing and you can now get paid for it. And that's the easy way out, right? You're very good at one thing and you're also getting paid for it. That becomes your full-time job. And eventually that's what you're doing for the longest time. Why this is bad is because you're no longer improving. There's no real difference between you and, let's say, I'm just taking an example here, a day laborer who's picking things up from one place and putting them in the other place. I'm not saying that's a bad job. I'm saying if you want to get into technology, then you have to be curious because technologies change very quickly. The world around us changes very quickly. Facebook had PHP as their primary backend for the longest time, and then they realized they need to move off. And recently, I think 3-4 years ago, they removed the last line of PHP from their code base, and they had a real big party apparently. So this just tells you that technology changes very quickly. And if you don't change with technology, you'll most probably get outdated very quickly. And the only way to become a fast developer is to keep upscaling yourself. And the only way to keep upscaling yourself is to be curious about technology. So what you have to do concretely is find problems around yourself which can be solved from technology. We will be solving such a problem today. And the reason I wanted to solve this problem was like, I have literally no reason to solve this problem. This was a client from a few years ago, and they have systems running. And I always had this at the back of my head around, I know this client is probably paying too much and there's a way to optimize this. And it's 1:53. So it's almost 2 a.m. right now. And I had a really long day, but it is this curiosity that keeps me up all night and like makes me solve this problem. And I think that's what compounds over years. If you are generally curious about technology, you will spend nights and hours. Again, avoiding any controversy. I'm not saying this is the right thing. I'm not saying you should spend 12, 14 hours a day working. I'm saying if you're curious generally, you'll try to solve problems better. For example, I've said this before, but the primary way we solve create websites is create HTML, CSS, JavaScript websites. But that's not optimal, and that's not what's used in the industry. What's used in the industry is React. Once you understand React, then there are other things that you can do with your front-end code. For example, you can break out components and use something like Storybook to structure components or make it easier for other people to contribute. If you've created a backend website, the first time you deploy a backend, it can be very rusty. That's when you're learning. But after you've done it once, you need to learn what's the better way of doing it. Should you directly be SSHing into your server? Probably not. Eventually, you should either use Kubernetes or find another way to deploy your projects directly from GitHub to a cloud, whatever cloud service you're using. Once you've done that, you need to understand how you monitor your code. There are people who stuck there. There are startups who are stuck here. All that these startups do is they have one backend instance running on AWS. Anytime they make a code change, they push it to GitHub, they SSH into the server, they pull their code and rerun it. If the website ever goes down at night, no one knows. They only know the next morning when their users complain, which is the worst way to build a website. But that's how a lot of Indian startups run, I've seen, or even in the US. So this is bad. If you keep doing this, like you're not learning anything. And also like this is not how eventually very big systems will be built. Eventually a big system will be hit by a lot of users, and one instance isn't enough. In that case, you'll need more. So you need to understand how auto scaling works. All in all, my point here is it's easy to reach a threshold in tech and then be very happy. It's very hard to chew glass. Chewing glass is a term that's used in one of the blockchains that I work at. And what it means is basically chewing glass is very hard. Not that I know, not that I've chewed glass ever in my life, but it'll probably be hard. And hence, if chewing glass is so hard, why do it? But that's the whole point that I'm trying to make in this video. You have to do hard things, and like chewing glass is just a statement or like a way of representing this, but it feels very counterintuitive to do this. Like, why am I up at 2 a.m. trying to solve this problem for a client that most probably won't, the value of which like most probably won't even accrue to me in the future, but I'm still doing it because I'm curious. And that's how you become a software developer fast, and like how you become a coder quickly. That's my 2 cents. With that, let's try to understand what's the problem we're solving here, and how we can make this slightly unoptimal code. Like me spending 2 hours today, like I spent 2 hours before this video to solve this, and I'm just showing you guys what the problem was and how I solved it. But me spending 2 hours today will probably save this client around 3 lakh rupees a month is my guess, and I can share the exact number next month when we run this code and it keeps on running for a month. And hence the impact that I could create in 2 hours is effectively 3 lakh into 12 months for how long this code has been running. That's a lot of lakhs, and eventually in some form or fashion this money will accrue to me. It will come back to me in various ways. So money is a part of it. It'll always be there. What's more important is if I've saved 36 lakh rupees to this person today, how much more money can I save? And then how much more value can I create? So with that, let's get into the AWS dashboard and show you around. So what this service that I've written does, it's basically similar to YouTube, where people upload a video. And when you upload a video on YouTube, you just upload one video and then it gets converted into various qualities. So you see like 720p, 1080p, so on and so forth. It's not expected from the end user to upload all of these qualities. It's YouTube's servers that do this job. And this is a very hard job. Like videos are big, and then converting them into multiple qualities is hard. And they also have to chunkify it, so on and so forth. That's exactly what this service does. It's called the Stream Transcoder. That's a name I picked for it. And effectively what it has to do is it has to keep pulling a queue which has a bunch of videos. The length of the queue keeps going up and down throughout the day as more and more people upload videos on their platform. And it needs to transcode this video. Transcoding is just a term that's used into multiple qualities and then post the URLs back to some service of that user. So that's the problem where this thing solves. The issue is this, as you can see, is part of an autoscaling group, which, as the name suggests, is a group of instances that should autoscale. But that doesn't happen here. Like if you look at the instances, there are 20 instances always running, and there was a reason for it. The reason is that usually when you're creating backend servers, they can be transitory. You're usually sending them a request and they respond back with a response. And then even if you have 100 servers, if 50 go down, your request will just go to another 50. If all of them go down and a new one comes up, your request will start going to the new one. These are short-lived requests, so these can sort of be very transitory and keep dying down and keep coming up. That's how a lot of servers work in the real world. But specifically for this service, after you've uploaded a video, it takes really long for it to transcode. So if your servers are very transitory, if you actually use the simple properties of an autoscaling group, things can go bad. Your video might be in the middle of being processed and your server might go down, and hence your video is stuck forever. So because of this issue, we never really added automatic scaling to this. So it was basically 20 servers running at all times, which is bad because you probably get traffic some portion of the day and then your queue is effectively empty and you have 20 servers running, which right now it's 2 a.m. So I'm pretty sure there's nothing running on these servers. So if I SSH into one of these servers, most probably my guess is there's nothing running. This one's actually running. So surprise, surprise. So currently the servers are running, but eventually throughout the day, at some point, the server will stop. The queue will become empty, and hence we have this fleet of 20 servers running on the internet, basically doing nothing, which is bad. And the client is getting billed for it, like they're paying their AWS bill. And if you look at the size of these machines, they're pretty big. So effectively the monthly cost of a single server is $30. And it's actually not too bad. Damn. I thought I'd save this client a lot of money. Probably not. I'll probably be saving them some money, but it won't be too much. But there's another service that's running right next to it that runs a very heavy server. And the same logic when applied there, I'm pretty sure it'll save them lakhs. This is the transcoding service. That is the encryption service, which is encryption is hard and takes a lot of CPU. So I'm pretty sure we can save more, but we can still save some. Here, what just showed you was the current pricing, and they basically have these 20 servers running all day. And what we want to do now is auto scale them up and down based on the current probably queue length. That's one good metric. But just to save time for now, what we'll do is we will auto scale this, and it's basically as simple as doing adding an auto scaling policy here, I think, based on the average CPU utilization. And what we're basically saying is let's target the value of 50. If the average CPU utilization is less than 50%, then decrease the number of servers and vice versa. So if I create this, my guess is, it's India day. Okay, so I'm in the US right now, which means it's India day. So most probably they have a lot of traffic. This may or may not auto scale down. Let's see. But what we've done here is if at any time throughout the day there are only 5 videos which are running on 5 servers and all of the other servers are empty, this will auto scale down. But the problem I initially mentioned, if you remember, is that these are long running processes, and if a server goes down while it's processing a video, it's bad. There are 2 ways around it. One is you can provide an instance timeout. So even if you terminate an instance, it stays up for like an hour. That's something we'll do. Second thing you can do is, which is something we implemented, is if some video gets picked by a server and the server does not respond back in like an hour, you can re-add that video to the queue, because you can assume that the server went down or something went wrong. So it is because of these reasons that now we can add such a simple auto scaling policy, which is something I just did. But the ideal way of doing this is probably putting each video on a server and like having some max server policy, just to make sure if 1,000 videos are uploaded, you're not running 1,000 servers. If you have 5 videos, you probably need 5 instances. If you have 10 videos, it'd be good to have 10 instances. If you have 100 videos, it'll probably be good to have 20 instances, and then your transcoding speed becomes slow. That happens with YouTube as well. So that seems like a better way to solve this. What we did just now would probably also start. Yeah, there you go. So the capacity itself went down because we're not completely utilizing it at the moment. I'm sure I think it's India day today, so it'll probably normalize around 9. We've over provisioned this just to make sure like things don't go down, and like $600 isn't too much for this service. So eventually this will go down and we've saved some money. Now, I could stop here, but I won't. I think there's another thing I need to do. The thing is, I have made this change and I am sort of assuming that this will work. It is possible, like a few things I can think in my head are, the queue length becomes really high, but the instance never reaches the maximum capacity, which here we've set as 20. That's bad. The second thing I can think of is the other way around, where this actually doesn't solve anything. There's a bug somewhere and it doesn't auto scale down, which I can probably see it is auto scaling now, so it's all good. So the case that I'm worried about is it goes down to 0. And it stays there even if the queue length is more than 100. So we have 100 videos in the queue and this thing doesn't auto scale up, and that's bad. So we should probably monitor this. And there are 2 ways of monitoring this. The bad way, which is I'll keep looking at the screen. That's probably bad. The good way is this happens automatically. And if there's ever an issue, an inconsistency, I get an email, I get a Slack notification, I get a phone call, and we're good. I mean, we probably won't be good if I get a phone call in the morning because I'm sleeping so late. But that's better than the client getting to know this information from a user. In this case, that will be the user calling the client and saying, hey, my video is not getting processed, which is really bad. So you need better monitoring here. So I've written some code. Again, this is something I was doing for the past 2 hours before the video. I've written some code which basically will alert. I mean, the eventual idea is for it to alert me, but what this will do is, this is a simple function I've written which will return true or false if there's an inconsistency. And the way I'm defining an inconsistency is that I've defined 2 variables: the max server, which is the maximum number of servers that we have here in the auto scaling group, which was 20. I've kept it as 30 because there was another auto scaling group that I was testing with, and the queue threshold, which is effectively at what point do we alert me, like call me. And the point that I've chosen is if the length of the queue is 50 and the number of servers is not 20, then we have a problem. So if you look at the logic, it basically finds the current capacity, which is basically current desired capacity, basically this number right here, which is slowly going down, 16. So this is the current desired capacity that we've found out programmatically. This is using the AWS API, very simple, in this variable. And we sort of poll the queue and find out what's the current queue length and store it in the other variable. And if the queue length is greater than the queue threshold, which means it's greater than 50, and the current capacity is not 20, we have a problem. So this is when we return false here, and I'll show how exactly this works and how exactly it will call me in a second. But I hope you get an idea of what's happening here. This function, which effectively is converted into an HTTP API, will in the HTTP API either return a 200 status code or a 400 status code based on whether or not this condition is true or false. So it's basically checking if there are more than 50 servers in the queue and the desired capacity isn't 50, that means this logic that I just, isn't 20. That means the automatic scaling policy that I just created is creating some issues and the thing is not scaling up when it should. So I think this is a decent way to track this. Again, what I've done is I've converted this into an HTTP API. Let me show you what that looks like. So this is the current queue length. There are 13 videos in the queue. So I think I could be wrong, but I think this should probably normalize around 13. So there are 13 videos in the queue, and there's another endpoint that I've created, which is, so this status endpoint returns either 200 or 400 based on whether or not that condition is true that we have just coded. So I've just basically converted this condition into an HTTP API, and the queue length, since it's currently 13 and the desired capacity is 16, the status endpoint is returning success. But let me change this number, and I will do that through my phone so as to not expose any secrets here. I'm going to add a few videos to the queue so as to increase the length of the queue. I suddenly remembered, before I do that, I need to show you how I will actually get pinged. So the way I get pinged is this endpoint that I created that returns success or failure. I've put into this service called Better Uptime. There are a bunch of other services out there that do the same thing, basically monitors an endpoint. And I basically mention if the HTTP status code that is returned is other than 200, then alert me, send an email, push notification, and then I'll show you a few other ways I can get notified. So I've created an endpoint, and this service called Better Uptime is pulling it. And as you can see, it says up here because this status endpoint returns 200. How do I know that? If I show you the network tab, it says 304 over here. 304 is basically, it's returning a cached response, but if I hard refresh it, it returns a 200, which is cool. That's as long as it is 200, Better Uptime, the service that is polling it, is happy. And as long as this service is happy, it won't ping me. But let me change the queue length now. Okay. I have changed the length of the queue. So if we check the queue now, it should probably return, 56, which is more than 50. And I think our auto scaling group will slowly auto scale. It's currently at 11. The status endpoint most probably should, not return a 200. It will most probably return some 400 or something like that. And hence, I think this alert should automatically go down. There you go. As you can see, it has detected an incident and most probably it will email me. I'm not showing my email on my laptop because I don't want to show everything. But if you see here, what those say, it says Better Uptime alert. Now this is good because, so all the 56 videos will get eventually processed, which is fine. What I've done here is if the queue length becomes very big and the thing doesn't auto scale, the client shouldn't face a problem. And that's why it's better for me to get alerted and basically just revert the change that I made. I'll probably just revert it right now and test this a little bit more before I actually release this in production. So let's just do that. So yeah, that's it. So what did we learn from this video? What we learned is I have no life. That's one thing we learned. And two, if you want to become a developer or like if you're actually passionate about something, I think you find love in that thing. And that for me is being up at 2 a.m. And solving these issues. But the original question of how you can become a fast coder, I think you can become a fast coder if you genuinely find this field interesting, which you can by just solving tech problems around you. There are 1,000 problems that can be solved. Every industry can be disrupted by tech. And I think in the future, every industry will be disrupted by Web3. That's speculation. But tech definitely can be applied everywhere. So find problems around you, solve them, and never stop. Keep upscaling yourself and finding better ways to solve problems. With that, it is 2:14. Thank you so much for sticking to the very end of the video, and hopefully you learned something. With that, let's end the video. I will see you guys in the next one. Peace.